Hi everyone, this is XYrate, and our team include Yiqing, Ruoxin, Wang, and Jinglong, Xiong. And in this project, our goal is to build a robust system to classify email intents into two categories. The first is the proposed, which is the sentence that suggest actions or events. The second is the request, which are the sentences that ask for actions, information, or commitments. And we approach this task by implementing two distinct models. The first is non-deep learning models. The second is a deep learning model. And this project required an end-to-end pipeline that includes data cleaning, feature engineering, hyperparameter training, model evaluation, and optimization. And as for our data set, let's talk about the data set. Our data set is derived from an enroll email crop-ups feature labeled sentences. And you can see that it includes two columns. The first is the label and the second is the sentence. And it includes two data sets. The first is the training set, which includes about 4,200 samples. The second is the test set, which includes about 1,000 samples. And as for the data cleaning, we remove the rows with non-values and duplicate sentences and normalize the type to lowercase and strip unnecessary spaces. And as for the feature engineering, for the ensemble models, we enhance the feature side by detecting URL and email addresses, category type balance, identify specific punctuations such as question marks, and checking for business-related keywords like meeting and agenda. And for the deep learning model, we tokenize the sentences using distilled tokenizer, converting types into fixed-length sequences with padding and attention marks. And let's talk about the non-deep learning model. As for the non-deep deep learning models, we implement an ensemble model using the voting classifier. And we combine the length of the linear SVM, which is efficient for high-dimension data, and the random forest, which handles nonlinear relationship effectively. And the third is the XGBoost, which optimized gradient boosting for better performance. And we also use the TF-IDF factorization, and which we transfer the sentences into numerical representation with about 5,000 features, and unigram and bellgram, n-gram were included for richer content. And as for the model optimization and selection for the model, we use the hyperparameter training. We use the great search CV to optimize the following parameter. And finally, we got the best parameter font, which is like that. And in that way, we got our performance, which is about 84% accuracy. And I can see that it includes not so well on the level 1 compared to the level 0. As for the deep learning model, we built a neural network using distilled, which is a lightweight and faster version of BERT. And as for the modern architecture, it has the distilled base, which encodes input text into a 300-dimension feature vectors, and use the CLS token to represent the sentence. And it also has a dropout layer, which is a certain percentage dropout rate, help to reduce overfit. And a fully connected layer maps the 768-dimension embedding to the two output classics. And as for the training configurations, it has the loss function and an optimizer, and the batch size is size as for, and we use for approach. And as for the optimized strategy, we implement with different learning rate, with different dropout rate, and deepening approach. And finally, we find the best parameter, which is like that. And with this model, we got our accuracy, which is around 86%. And from now, we have got our two models, and compare the two models, we can find some interesting things. And first, for the training time, the non-deep learning model is quite faster to train due to a simple architecture, and the deep learning model is more computationally expensive, required GPUs for optimal performance. And as for the generalization, the deep learning model struggled with sentences containing complex semantic structures, and the deep learning model demonstrated better generalized for unseen examples. And as for the performance, we can find both models achieved a good overall accuracy. However, the deep learning model shows slightly advantages in handling enhanced email structures. And as for the expected and unexpected outcome, we expected the example model to perform well due to its diverse-based classifier. However, it relies on injured features, limited its ability to generalize complex sentence structures. And as for the improvement in the future, we identify several ways for the improvement. First is the data augmentation. We can expand the data using the segment replacement or back translations. And we can also use do some class balancing. We can address the label imbalance. We can find that the label imbalance with the oversampling or weighted loss functions. And we can also use some learning rate schedule. We can adopt dynamic learning rate to stabilize training. And in summary, this project allowed us to explore and compare the strengths of the traditional machine learning and deep model and the deep learning models. Both methods achieved competitive results, and we identified clear directions for future improvement. Thank you for watching, and that's all of the presentation. Thank you.